Hi, welcome to my little mini series on the four pillars of object-oriented programming, namely encapsulation, inheritance, abstraction, and polymorphism. It's one of the most asked questions I usually get on interviews, and it is expected of devs, a lot of devs, to know what the four pillars are and why they're used. Now, whether or not you're a fan of object-oriented programming or not, it is a very popular paradigm, probably the most popular paradigm in how to write software. And the four pillars are all about how do we write software that will be easy to change in the future, that will be bug-free, and allow software developers to work as a team, even though everyone, for example, doesn't necessarily know what everyone else is doing. So these four pillars help us write software that accomplishes these tasks. And so it's not just theoretical, it's not some ivory tower idealistic thing, it's actual pragmatic. How do we think about writing classes? How do we think about how objects interact with one another? And so today we're going to go over encapsulation. Essentially, the way to understand encapsulation is objects are on a need-to-know basis. So the data coming into an object and the data coming out of an object need to be controlled. The analogy I usually give is McDonald's. So when you go to McDonald's, you walk up to the counter and then you order. There's a menu, there's a person standing behind the register, and then you order your food, and then they give you a number, and then you wait, all right, and then you get your food out. Okay, so you have only so many things you can do with McDonald's, right? The input, the data that's going in is through the cashier, all right? And the cashier can correctly sum up your total. They can correctly make change. They can correctly answer questions about the menu, right? And that is, your window into McDonald's. And then when you go over to the other side to get your food, what comes out, the data that comes out, your food is, packaged for you on a tray, and you get a cup. Everything's like nice and organized. When you go to McDonald's, you can't walk around the cashier behind the counter, head straight into the kitchen and start making your own burger. Okay, that does not work. It is not an open kitchen. There are rules for how you can operate with McDonald's. Okay, the data coming in and the data coming out are controlled. Okay, McDonald's isn't the inner part of McDonald's. The kitchen, the manager, how all that stuff works is encapsulated. Okay, you can't just walk in and do what you want to do. The way data comes in and the way data comes out is controlled. So the typical example I use is bank accounts. So even if you're not a Java developer or you've never seen Java in your life, if you've done some basic object-oriented programming in another language, like C#, for example, or JavaScript, you should be familiar with the class keyword, and you should be able to follow along. So objects have properties and they have behaviors. So bank accounts, it has balance and account owner. Those are its properties. Those are things that describe the bank account. Bank accounts are things with a balance. Okay. Also, it points to a real life thing, right? Real world bank accounts do have balances and account owners. So that's the other thing about object-oriented programming is because we can create classes that map to real world things, it helps us as human beings to reason through our software. Because if everything were just numbers, it'd be harder, but we can label things according to what they are in real life. I also have this static property called overdraft fee, and if you're not sure what static means, the easiest thing to think about is that this is a constant. It doesn't matter what bank account it is. It could be my bank account, it could be your bank account, it could be Bob's bank account. The overdraft fee is always going to be the same no matter whose bank account it is. Okay, that's why this is static. It's constant, doesn't change. And I also have final here. Final in Java means read-only, basically. It's set and that's it. Once it's set, then you can't change it. So const in JavaScript. All right, what can we do with a bank account? Well, we have deposit, withdraw, and apply overdraft. So what do all these mean? Basically, you can think of the bank account essentially has this inner state of what the current balance of the bank account is, and money going in is a deposit method, and money coming out is the withdrawal method. Okay, so the deposit method and the withdrawal method are the ways in which that data should flow into the bank account and data should flow out of the bank account, because that balance is the most important thing. That balance has real world consequences. When I log into my banking app, that balance had better be correct. All right, but we've got a couple potential problems with this bank account class. And so let's take a look at them. What I'm going to do is I'm going to go to my main class. In Java, we write everything in public static void main, except for newer versions of Java. So this is just basically, I'm going to write some code where the program would normally start. So if I create a bank account, I'll call this new bank account. or maybe like a Bob bank account. I like that. Equals new bank account, and it starts off with $100, and Bob Jones is the owner. All right, so Bob goes and deposits, I don't know, $200, and then Bob will withdraw 300, like I don't know, $100 because he needs it to go out or whatever. And then we probably will need, I can go ahead and S out Bob's bank account dot balance. All right, so there should be a specific balance that we expect, right? So if it starts off with 100, we added 200, we took away 100, we should have 200 at the end. So let's go ahead and run this. Okay, correct, 200. Okay, so we're, our bank account application is working the way we expect it to, except there's a possible problem. And the possible problem is that we can change the balance without using deposit or withdraw. Okay, that's the problem. And the reason is because if we look at it, balance is public. Okay, this public modifier basically means that you can deal with the balance in any part of the program. It's not restricted. There's no restrictions on who can access the balance of the bank account. So since that's the case, there is literally nothing stopping me. So let me go ahead. Let's say a new intern comes and they say, okay, cool, I want to add $200 to the balance. Notice how I'm not using the deposit method. I'm not using the withdraw method. I am just straight up saying, cool, add 200 to the balance. Add 2,000 to the balance while you're at it. Okay. And so now, in our scenario, we were supposed to have $200, and we're only supposed to use the deposit and withdraw method. But because we're allowing people to just do what they want with the balance, what's to say that this can't happen, right? This is not the correct answer. Okay, the person circumvented the ATM machine. The ATM machine gave them the ability to deposit money and withdraw money, right? But they went behind the teller. They went to the bank. The teller said, "Hi, how are you doing today?" The person was like, "Whatever. I'm going to go behind the counter and just add $2,000 to my balance." Okay, no, it's not the way that works. You walk up to the teller. She allows you to deposit and withdraw, and there are rules in this house. So this is not going to work. Now, you may be thinking to yourself, well, maybe we don't allow that. Maybe we just, as programmers, just say, okay, I'm not going to do that. The problem is, again, there's two things. Number one, this is a team sport. Someone else is going to come to your code and they're not going to know your thought process. They can't read your mind. They may not even necessarily be working on the software concurrently with you. You could be at a company, make a piece of software. Have a startup and become a gajillionaire and fly off to Cancun. And then some other poor schmo comes in after you and has to work on your code. They don't know you. You don't work at the company anymore. So how are they supposed to know what you intended to do with the class and what rules they're supposed to follow? Well, why don't we make these rules explicit so that everyone can understand them? So what I'm going to do is I'm actually going to put the code back for a second. All right. And then I'm going to change this from public to private. I'm going to make private double balance and private string account owner. What private essentially does is says, okay, cool, bro. This property balance is variable here. You can use it inside the bank account. So if we're inside the bank account class, do what you want with it. The second we leave, though, we can't work with it. Notice how Java has this as red, meaning that I have a compilation error. Java is angry with me. You can't do this. Balance, if you hover over it, balance has private access, which basically means, hey, sorry, you can't do this. Like, literally, I can't run my program. If I try to press play, it won't build. It will give me errors that I have to fix before I can move on with my life. So this way, it makes it so that, hey, you can't do this. So this is what I meant by making the rules clear. The rule is that balance is not directly accessible. You want to change the balance of the bank account? Well, we have a deposit method and a withdrawal method, and that's what you've got. Those are your choices. That's how data comes in, and that's how data comes out. That's how the state of the bank account changes. The balance of the bank account is its state in this case. So those are the rules. Well, Jonathan, we can't display the balance. Well, that's why we have getters. Okay, so let's make a getter. So I'm going to go ahead and I'm just going to use IntelliJ. It has a generator, which is pretty cool, that allows you just to make a getter because I can't be bothered. All right, there we go. And now I'm going, instead of doing bank account.balance, I'll do bank account.getBalance. Okay, and now my code will compile and run. and I will get the proper balance for my bank account so long as the deposit method and the withdrawal method work the way that they're supposed to. All right. So as you can see, we've kind of it's not about like it's about building rules that people have to follow so that your code has no chance of breaking. Because here's another thing. You might work on code today and you may not touch it for a year and you may come back to it later. Who's to say you remember what you were thinking a year ago, right? Especially when you're doing something complicated like software. So by having these rules set up, there's no room for mistake. You can't do it. Now, there's another, don't have to do this just with properties. You could also do it with methods. So here I have an apply overdraft method. So the idea is that if someone withdraws their account and they go below zero, it applies an overdraft fee. I don't like overdraft fees, but a lot of banks will do that. So this right now says public void apply overdraft. So you probably already know where this is going. Who's to say that I can't do this? Okay, just some disgruntled employee at the bank starts applying an overdraft fee to Bob's account, even though Bob is not overdrawn in his account. Okay, the withdraw method here has logic that checks to see if your balance is below zero and whether or not to apply an overdraft. That logic, whether or not to apply an overdraft fee, is encapsulated, right, in the withdraw method. The withdraw method is responsible for figuring that out. But if this is open to anybody to use, I could just start applying an overdraft fee to your account without following the business rule of you have to have actually gone below zero. So this should not happen either. I should not allow this. What I'm going to do is then switch this from public, you guessed it, to private. All right. So now it's within the class. So the apply overdraft method is inside the bank account class, which means the withdraw method can use it. Okay, so I can take in the withdraw method, I check if the balance is below zero, and then apply the overdraft. That's fine. We just can't use it willy-nilly out here. So overdraft fees can only be applied if the withdraw method is called and the balance goes below zero. So now, as you can see, from the perspective of someone creating a bank account and using it in the main class or wherever they're using it, there's rules. There's things they can and cannot do. Okay, so if you want to use deposit and withdraw, then that's fine. We could if he'd like withdraws $500, all right, which is I think should put him definitely below. Okay, then he gets that overdraft fee, negative $335, and that's what should happen. So our program is working as intended, and not only is it working as intended, we didn't give anyone else the option of breaking it. Okay, so that is the subtle point about encapsulation, is that by encapsulating the balance, by encapsulating the data that goes in and out of the bank account, namely how the balance changes. Okay, we've said deposit and withdraw are the ways in which you can change the balance of the bank account. By setting those rules, by essentially giving people no choice but to use those two methods, we have cut out potential bugs, potential human error. And so that is really what we want to be able to do, because now I can go to sleep at night and bank accounts should work, generally speaking, how I want it to work. And if we have any bugs or anything, it'll be easy for me to like localize and figure them out. All right, so this is encapsulation. Again, encapsulation is basically about controlling how data goes in, how data comes out of a particular object. All right, we've encapsulated it. It has its own internal state, internal properties like balance and account owner. I'm using the word internal because you could think of an object sort of like, I like to think of like a sphere, and then inside is the data. All right, so again, data coming in, data coming out, the data inside of it changing. It's encapsulated. All right, you have certain ways in which you can interact with the object, and because we are limiting how we interact with the bank account, we are therefore reducing the opportunity for someone to mess up and create a bug. All right, so hopefully you enjoyed this. That was encapsulation. And again, if you're not a Java developer, hopefully you were able to follow along with the basic idea. It doesn't matter if we're doing C# or JavaScript. The idea is exactly the same. It's just the programming language will dictate like what you actually type and what syntax you can use to accomplish this task. All right, in the next lesson, I'm going to talk about inheritance, which is the next pillar of object-oriented programming. So when that video drops, please keep a lookout for it. And if you enjoyed this, please like and subscribe. That's it for encapsulation. Okay, see you guys next time.